Here we go. So the 3.1 handout. And I'm going to do now problems number, not 3, we did 1 through 5 already. So 6 through 11. I'm going to cover number 6 through 11. Like I said, 18 to 12, working backwards, already on the website, on the YouTube. And we already did 1 through 5 on the YouTube. So all we got left is 6 through 11. So they'll all be out there for you to study. And remember, and I'll pick exactly 5 of these to be on exams, because I know these are hard, so I'm not gonna mix them up and make creative new ones on you. That would be hard. I know these are difficult for students, and so I promise it'll be exactly 5 of these. I'll shuffle the options and I'll throw in an option E, and 1 or more of them may be E. So otherwise it's the same though. Exact same functions, everything else is the same. Exact same questions, same options even with an E.
So you're going to have only these type of questions, 5 of them?
Oh, no, there'll be other stuff too from the other sections. Yeah, our exam that we take next Tuesday will have all, this is just the first section in Chapter 3. It'll have other sections, but I'm just saying the ones from this section, all I will give you from this section will be literally 5 of these 18 problems. They'll be the exact same question with the exact same options in a different order with an E option thrown on there, and E might be valid on one of them. So there we go. So that's the plan. So learn these. In other words, learn these well. Practice these until you can really do these and you'll be good on the exam. Okay, so number 6. What does number 6 say? Tangent times cotangent minus cosine. I'm not even going to put the x in there. Tangent times cotangent minus cosine. So we're supposed to use those properties, all the different properties. So what should we do on this one? What do you think? What should we do? Any ideas?
Distribute.
Yeah, just distribute. Just take that tangent and go boom, boom. Right? Something outside parentheses multiplies into the parentheses, doesn't it? So just multiply into the parentheses there. So what do we get then? We get tangent times cotangent minus tangent times cosine. Okay, so far I just took that tangent and multiplied in. Like that. Right, good. And now, what is tangent times cotangent?
1.
Yeah, do you realize that this is 1? Why? Because cotangent is upside down a tangent. If you want, I can take it a little slower. This means tangent times 1 over tangent, doesn't it? That's 1, isn't it? Because that's tangent over 1 times 1 over tangent. Everybody good with that? So far, so good? Right, and now, what should I do with tangent times cosine?
Can you cancel out the cosine?
Yeah. You're seeing that because what are you doing there, Bernadette?
I'm multiplying sine over cosine times cosine.
Yeah. So you see what she's saying? She's right on the money. She's taking that tangent and saying, how can I break down tangent? What is tangent? Remember what tangent is? Sine over cosine. See what she's noticing? Times cosine, right? Everybody see that? So these are kind of tricky. There's a lot of different properties that could be used at different times. So sine over cosine times cosine. And remember, whenever a fraction interacts with something that's not a fraction, put it over 1, and then the cosines cross cancel. And so this thing is 1 minus sine, which is like answer D. We got it. Everybody see that? How number 6 works?
Wait, can you explain again the tangent over 1 times 1 over tangent?
Yeah, so cotangent is 1 over tangent.
Oh, okay. All right.
And then they cross cancel. Is that good? So yeah, you want to remember which ones are upside down from which ones, and that helps. Good? Want to try another one? We'll go on. Let's try number 7. Number 7 says sine squared plus sine squared cotan squared. Yeah, try that one. Try that one. Okay, any ideas? What should we do?
Factor out sine squared.
You could. You could factor out sine squared.
Cotangent cosine squared over sine squared.
Can you just do 2 sine squared?
There's a couple ways you could go. We could do 2 sine squared if it didn't have the cotangent with it. So in other words, this, and if it was just sine squared plus sine squared with nothing else, yeah, that'd be 2 sine squared. But because he's got a cotangent, you know, the one thing, what's good about these, I know these are painful, but it's kind of like exercising. It's really good for you. This is like algebraic exercise. It's really, really good for you. And we'll talk about all kinds of rules involving factoring, and if you want to go on, if you want to go to pre-calc and count and go that way, this is almost the best thing in the class for you because it teaches all those rules. So, for example, like let me just throw out one thing. How you want to look at things like this in math is terms. Terms are I'm into this one word, things separated by pluses and minuses. So notice this plus right in here. That's the separator between those two. That's how you should visualize it. That's how you should look at it. The pluses and the minuses are the separators. Now they're also glue. I've used that analogy, like Costco glue, and they do that too. They're really the tricky elements of algebra. Times and divide are easy. There's nothing complex about multiplying and dividing when it comes to algebra. But adding, subtracting actually sounds funny. It seems like it's easier operation, but all the tricky rules involve adding, subtracting. So look at adding and subtracting is separating. So you should look at it like those are the two terms. So that's why Benjamin is saying correctly you could factor out sine squared. Turns out you could make it work that way. I could do that. Then an easier way where things will go a little smoother, a little quicker, is if you take that cotan. Somebody was saying that one. That's right. What is cotangent, remember? Cosine over sine. Yeah, it's 1 over tangent, but it's also cosine over sine. It's upside down of tangent. Remember, tangent is sine over cosine, so cotangent is cosine over sine, right?
And you keep the squared on both of them. Right?
Yeah, so cotan squared will be cosine squared over sine squared, right? So what does that mean? So what does that give us then? So that would just bring this down, sine squared. Bring this down, sine squared. And then the cotan, I'm going to replace him with cosine squared over sine squared. And this is times. Yeah, and why that's such a good thing to do is because now this is over 1 and these guys cancel, don't they? Cross cancel. Anything with that's not a fraction, put it over 1 and they cross cancel. So what does that give us? Well, that's sine squared plus cosine squared. And that, remember, that's the most important theorem probably that you want to be aware of. Is sine squared plus cosine squared is 1. That'll come up all the time in this handout. So be watching for sine squared plus cosine squared. If you see it, it's 1. We're done. The answer is A, which is 1. Now there's other ways we could have got there. Benjamin's idea of factoring out sine squared would work as well. Just be a different road. Yeah?
Can you rewrite like the rules out for like cotangent?
Those 3 things, yeah. I will on the next one where we have the next one. Yeah, I will. Those 3 Pythagorean identities, yeah. Questions on that one? All right, let's go forward to number 8. So sine squared plus tangent squared plus cosine squared. So see how those are 3 separate terms? Let me write out the 3 good formulas. Sine squared plus cosine squared is 1. And tangent squared plus 1 is secant squared, and or I think I wrote it the other way. It doesn't really matter, whichever way. And 1 plus cotan squared is cosecant squared. Yeah, those are the three probably most important formulas to have right at your right hand as you crank through these. You just want to have those available. All right, we good to there so far? Now, any ideas? What can we do on this one?
Well, I originally thought that you could take the sine squared and the cosine squared and make it 1.
That's a great idea. Let's do that. See the sine squared plus, it doesn't matter that they're right. You can switch the order, right?
Because they're addition.
Yeah, adding the order never matters. Just think about numbers. 2 plus 3, 3 plus 2, either way is 5. Order of adding never matters. So let's just say those two make 1, don't they? So this is 1 plus tangent squared. The sine squared and the cosine squared vanished and together became 1. Does that make sense?
Yep, that's a lot of directions.
Isn't it?
But 1 plus tan squared equals secant squared.
Oh.
Everybody seeing that? Everybody okay with that first step? See what happened? The sine squared plus cosine squared became 1.
That's the other rule.
Everybody
I
see
didn't
that?
Look at it.
Yeah, no, it got me the first time too.
Right? So it became 1, and then 1 plus tangent squared. That's right here. 1 plus tangent squared is secant squared. Done. That's B. We good there? So on we go to number 9. So try number 9. Cosecant times cotangent over secant. Okay. Cosecant times cotangent. You know what I would probably try to do? Is break those all into sines and cosines. I would probably just rewrite all of those as sines and cosines and see what happens. So, how you doing? Do you know how to rewrite them? So, what is cosecant in terms of sines and cosines? 1 over sine. What is cotangent in terms of sines and cosines? Cosine over sine. Oh no, I want to make them into, it is 1 over tangent, but I want to make them into cosines and sines. And what is secant in terms of sines and cosines?
1 over cosine.
1 over cosine. Are we all good to there so far? Everybody see what I did? I just rewrote each of those three in terms of sines and cosines. Right? You okay with the cotangent? Remember, tangent is sine over cosine. Cotan is upside down, cosine over sine. Question, Ani.
So does cosecant and secant not have anything where it's just like, for cotangent you changed 1 over tangent to like cosine over sine?
Right, so I could write that formula over here. So tangent is sine over cosine. So cotan is upside down to that. Cosine over sine. Right.
But cotangent could also be 1 over tangent.
It could, but remember I didn't want to go, I wanted to go to cosines and sines. Why? Because then they're all cosines and sines, hopefully they can cancel and stuff.
No, well, like, my question was, like, does tangent also have, like, for cotangent to be 1 over tangent, does
Right.
tangent have another one besides sine over
He's just
cosine?
1 over cotangent.
Oh.
Yeah.
Alright.
Is that good so far? Now, what do you do when you have a fraction on the bottom of a fraction? Flip it up and multiply, right? Because dividing is upside down multiplying.
And you have to do it to both.
Oh, no, this is actually one term. If there was a plus or minus in the middle, then they'd be two separate terms. They'd both get. That's a good thing. That's good. That's why it's so important to think about pluses and minuses versus multiply, divide. I can always tell a student who's starting to more and more get the deeper rules of algebra when they're really focused on the relationship between the things. You really want to start paying attention. Like younger, when I teach like pre-algebra and people that don't have much of it, they never consider what's in the middle, whether it's times or adding, subtracting. I've noticed that trend. So as you move up the line, you want to more and more think about not just what's there, but what's between them, their relationship that's between them. So if it's times between them, then they're one thing, so to speak. When you have adding, subtracting, that's a separator. Glued, but separator. Anyway, so grab that 1 over cosine, flip it up. So we have 1 over sine times cosine over sine times cosine over 1. Does that make sense what happened there? So I just brought down the numerator and then flipped up that cosine over 1. So what is that? Did I lose you there in that step? So I brought down the 1 over sine and the cosine over sine. 1 over cosine I flipped.
Why didn't you first work out the top and then
You could have.
and then you can flip it?
Yeah, that might be cleaner. I like what you're saying. Either way, it's totally fine either way. We could totally do that. So what would that top be? The top would become cosine over sine squared. Right, see what Jose's saying? Just do the top. 1 times cosine is cosine, sine times sine is sine squared. And then flip that up. Either way, it's totally good. Grab this, flip it up. So this will become cosine over sine squared times cosine over 1. Grab that, flip it up, cosine over 1. We good there? And then cosine times cosine on the top. Cosine squared. Over sine squared. We're close. Y'all seeing that?
Where it's cosine over sine squared over, it was over cosine, right?
No, it's over 1 over cosine. See?
Oh, that's right, okay.
We good to there then? Ani?
Couldn't you just done sine over sine, multiply that to the cosine over, well, before you erased it, weren't you supposed to find like a common denominator?
No, that's adding, subtracting. Multiplying, we don't have to mess with common denominators. We just multiply them. Anything goes. Yeah, good question. Yeah, so adding, so there's always the difference in rules between adding, subtracting things and multiplying, dividing things. So adding, subtracting fractions requires common denominator. Multiplying, dividing doesn't. Remember, adding, subtracting is always the harder in every situation. Adding, subtracting with fractions requires common denominator. Multiplying doesn't. All right, so we're good to hear cosine squared over sine squared. What is cosine over sine? It's right here on the board. or the board, the screen. Cosine over sine is cotangent.
Squared.
In this case, squared. Right? Y'all seeing that? See it right here? Cotangent is cosine over sine. So this is cotan squared, isn't it? See that? Cotan is cosine over sine. So cosine squared over sine squared must be cotan squared. So cotan squared, that's our answer, A. Is this making sense?
So it doesn't have to fit exactly, I mean, you can pretty much make it up, I mean, if it has a square on it, you can make a new one up, it'd be cotangent squared?
Well, no, it's what's true. Let me show you. So we know, I don't want you left with that impression, Jose, that we're kind of making this up as we go along. That's something that's true, right? Cotan is cosine over sine. Okay, so then what is cotan squared? I know you feel like I just put the 2's on it, but no, let's think about what's actually true. Cotan squared, what does it mean to put a 2 on anything? If I have a number like 7 and I put a 2 on it, what does that mean? What do little 2's in the upper right-hand corner mean? Doesn't that mean 2 of them multiplied? So doesn't, therefore, this mean 2 cotangents multiplied? Has to mean that, right? Okay, and what is each of these cotangents? Each and every cotangent is cosine over sine. So the second one is also cosine over sine, isn't it?
Yeah, but what I'm saying though is that it wasn't part of the original three identities. You added another one in there, which is
Oh, well, I'm going to add a million of them in there. Yeah, so it's like those originals are building blocks
okay.
with which we're going to build all kinds of things. Yeah. So does it make sense what I'm saying that I wanted to prove to you?
No, I understand
Cotan
that.
squared, so that'd be cosine squared over sine
I
squared.
just thought it had to match those only three. I didn't
Oh,
think it
yeah,
had
no.
to do it.
Yeah, I'll use those to build other things.
Okay.
Yeah. Is that good on that one?
Because you gotta do both of them, okay.
Yeah, you can do FOIL for this.
Yeah.
So ready for number 9? That is number 9. Number 10?
10 is easy. Put that one on the test.
Is that a good one?
Put that one on the test.
Yeah, that is a super easy one, isn't it? So really all we got left is number 11. Let's do 10 real quick. Yeah, 10 is tangent times cotan. Yeah. What's tangent times cotangent?
1.
Yeah, right? Because cotan is 1 over tangent. So over 1 they cancel, it's 1. So that's answer B. Super easy one. And finally, number 11. So last one. Now I'm going to go to a fresh screen here. Number 11. Tangent plus 1 times tangent plus 1 minus secant squared over tangent. Good to there? Oh, well, I guess that's the first step. So what should we do first?
FOIL?
We get rid of the tangents?
Yeah, let's FOIL out. Get rid of the tangents?
No, the parentheses thing.
Yeah, the parentheses, yeah. Multiply through the parentheses. Multiply through the parentheses.
It would be that into x minus 1.
Yeah, so let's go through it. So you okay with, remember how to multiply things from algebra that are in parentheses?
Mm-hmm.
So I'll take this one first. I'll go boom, boom. So tangent times tangent, tan squared, plus 1 times tangent is 1 tan, plus, and then boom, boom, 1 tangent, and 1 times 1 is 1. Minus secant squared all over tangent. Good so far?
And I cancel out one of the tangents.
Well, hold on for just a minute. So is everybody good to there? Is everybody okay with that FOIL? See how I just foiled that up? Remember FOIL from your algebra days? First to both, second to both. Good, okay. Yeah, now what can we do?
Get rid of tangent because it's fractions.
Just come in here, just cancel those. Is that good? Really important that you know that's illegal procedure.
Pluses and
You're going to go higher in math. So it's really easy. I know tons of people make that mistake. That's why I do the whole Costco thing. Now, I did tell you the Costco thing, right?
Yeah.
Right?
Yeah.
So as you go to Costco, so pluses and minuses are like glue, right? Like at Costco, you can't buy just one whatever, spaghetti sauce. It's packaged to the other. You have to buy the whole package. So pluses and minuses are like that in algebra. So what that means, see how these pluses and minuses are up there? They're gluing it all together, aren't they? They're gluing it all together up there, which means that whole numerator is saying, I'm a package deal. You go like that, or you don't touch me. You buy all or nothing. Pluses, if you want to really see it, pluses and minuses that way.
But you can't take tangent squared plus 1 is secant squared.
Yeah, we'll get there. I want to talk about what we can't do first. So you can't. So everybody see that we cannot cancel those two tangents because it's part of a glued package. Now, if those were times, that would be great. If this was just multiply, I would totally just cancel those. That'd be exactly the right thing to do. So that's why what's in the middle is so important. So you want to more and more realize that pluses and minuses in the middle glue things together, making them a package deal, all or nothing. All or nothing. It's just like what I tell my daughters. If the young man is interested, he can have all of you, that's called marriage, or he can have nothing. I mean, my daughters are older now, so that is their conviction as well. Anyway, I'm sure that's fresh in my mind. My wife and I just had the talk on Sunday with a young man who is interested in one of our daughters, and we gave him the A-OK. We like him a lot to pursue our daughter. But anyway, so I'm sure it's fresh. I know you probably think that's old-fashioned, a lot of people do, but anyway, my daughters are very happy with the whole thing. So I'm giving you another analogy. I'll give you two analogies. All or nothing. Plus and minus are all or nothing. All or nothing. So we can't do that. Yeah, so Pauline, your idea is a fabulous one. What is it? What were you saying we do? Let me rewrite what we had here.
Tangent squared plus 1 equals secant squared.
Yeah. Yeah, exactly right.
And also we can do 1 tangent plus the other tangent, 2 tangent.
Yep, you guys are rolling it out. All right, so tangent squared plus 1. Grab those two. So Pauline's thinking of those properties on the side. Let me write them again. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And cotan squared plus 1 is cosecant squared. Remember that, Jose?
Do you have to go across for the 1? Can't you get the 1 that's right next to the tangent square?
Oh, good question. He's attached. He's not a separate one. Good question. So remember, this is the separator. Now, if there was like a plus right there, then he'd be separate, and I could grab him. Really good question. Yeah. So do you see how all your guys' questions are all about the difference of what's between these things? So again, the main idea, pluses and minuses. It's kind of weird how pluses and minuses do two things. Because I keep telling you, they're glued. And then I go, they separate. So it's kind of both. That's why it's a little tricky. So pluses and minuses both separate, like at Costco. Right? Those are separate spaghetti sauces or whatever. Milks, whatever. But they're still plastic together. That's what pluses and minuses do. They separate yet are glued. So Jose's question is good. I can't grab that one because it's not even separate. It's just part of the tangent. So I can't grab it separate. Good question. So that's how I learned algebra. All these you got to ask all those good questions. So tangent squared plus 1. So those two become right over here secant squared. So I can replace those two with secant squared. And then what else do we have? 1 plus tangent, 1 plus tangent. Zuhal, you think you're saying that right? 1 plus tangent, 1 plus tangent.
Equal to 2
I'm sorry, am I saying that wrong? 1 tangent plus 1 tangent
tangents.
Two tangent.
is 2 tangent.
And then we can get rid of the secant one.
That's right. These cancel. Am I going too fast? Am I losing you? So 1 tangent and 1 tangent made 2 tangent. Remember when you add? Are you okay with those rules? When you add things, you add the numbers in the front. Whereas when you multiply, like tangent times tangent made tangent squared. Huh? You good with all those differences? And then here, yeah, the secant squareds drop out, don't they? You see that? So then what do we got? 2 tangent over tangent.
We can get rid of that.
There it is. What? That's B.
The other way, the way I did it, there was the option for it for 10, just for.
Oh, was there?
Yeah, I did all the work and I got.
They put that option there? Like as the wrong answer?
It was so much work for this.
Because he eliminated the tangent.
Oh, I see. Yeah. Right, there was a way to make that happen. Gotcha. They're trying to trick you. Yeah.
Is that saying there's 2 tangents, like tangent, and then 1 tangent on the bottom?
No. That means there's the number 2 times tangent. 2 tangents would be tangent squared. Good question. See the difference? It means the number 2 times tangent. If you wanted or you could say it's tangent plus tangent, but it's not tangent times tangent. That'd be tangent squared. So it's 2 tangents added is what that means on the top. It's 1 tangent and 1 tangent added, not multiplied.
Can we just do those as like fractions? Like
Yeah, it's just a fraction. You're totally right.
this is a 1 over 2 over
It's
1.
just the number 2 times tangent over tangent, tangents cancel. Yeah, that's totally correct as well. And there we go. So some of the harder ones I did with the other group, especially number 18 and number 13, are super tricky, which is the very next one. No, 2 more away.
No, 12 is pretty.
12's not super easy either, huh?
12. I'm stuck on 12.
Yeah. So they're all out there on the YouTubes for your perusal. So let me go ahead. Is that going to be good? How are we doing on time? Well, I think I could probably do here. Let me do number 12. We could probably do one more. I think even though we're overlapping a little bit, I think we're okay. I'm going to do number 12. I'm just going to write C and S because they're all cosines and sines. I want to save time and space. I'll just write C minus S over C plus S minus C over S.
So we need a common denominator.
Yeah, good job. Good job. You're on the right track on this one, Angel. That's right. Common denominator. Common denominator.
And then we will have like sin x cosine x minus 2 sin 2x, and then the same thing we can do like 2 sin x cosine x, and then minus sin x to the power of 2x, and then minus cosine x to the power of 2 is equal 1. We can do minus 1. It will be like just 2 sin x cosine x minus 1 over sin x cosine x.
That sounds generally right. It's hard for me to follow all the details, but yeah, I think that's right. No. Yeah, so take some of those and get a common denominator. You know what I mean by common denominator. Now, how's your fraction skills? You'll need, if you want to go pre-calc and calc, you got to be nails on fractions. They can never give you trouble because they are everywhere in pre-calc and calc. So do you know how to get a common denominator there and put those together? You can do it. It just takes tons of time and practice. You can master it.
Words.
Just multiply.
So you know, just so I want to make common denominator. Do everybody know what I mean there by common denominator? You want to come in here and multiply
So say it was like 2 and 3.
S top. That's an S. Not very well done there. I want to multiply S top and bottom, and here C top and bottom. See how that'll make both denominators be SC? And see why we have, because here they're added, huh? When they're added, we have to make the bottoms the same. Right? Remember those rules? Whereas if those were multiplied, we wouldn't even care. Everybody good there? So common denominator is SC.
Now we could just put it all under SC.
Yep, and yeah, now it's one big bar with SC. Right, good, because they both have the same denominator, don't they? So just multiply out that top. So that's going to go boom, boom. We get SC minus S squared plus boom, boom, SC minus C squared. Everybody good to there?
Yeah, I got stuck here. Sorry. I don't know what
Is that all making sense so far? Can I cancel the SCs? Like that. Is that okay?
No.
Costco says no, right? Pluses and minuses, those are all glued together on the top, which makes a package deal. Buy the whole package or none of it. It's all or nothing, not part. So can't do that. So, well, then what do we do? Well, I would just do like terms. What is SC plus SC? Yeah, because it's an invisible one. So remember, when you add letters, you add the numbers in the front. When you multiply letters, that's when powers change. Right? Got all those rules down? 1 SC and 1 SC is, I'm going to change the color here, is 2 SC. So it's going to be 2 SC minus S squared minus C squared over SC.
Oh, that equals 1.
You good so far? That's good? Now, when you see S squared minus C squared, what should you think of right away?
1 minus 1.
Yeah, remember the Pythagorean identity. Sine squared, I'll write it over here. Sine squared plus cosine squared is 1. That's the most commonly used. When sine squared plus cosine squared is 1. So what? This is not sine squared plus cosine squared. It's got a minus. Can we use it? If so, how?
Wait, is it negative sine squared minus cosine squared, or is it
Yeah.
just sine squared minus?
Minus sine squared and minus cosine squared. They're both minus.
Yeah.
So couldn't we then just put negative 1?
Yeah. So you, Bernadette? Yes. Factor out a negative 1. Now, how are you at that? With signs and factoring out in GCF? How are all those things? You want to go the way of pre-calc and calc? Those are things you need to know. So, in other words, what Bernadette's saying is exactly right. When you look, you have to do something. The signs aren't quite right. It's supposed to be sine squared plus cosine squared, not minus. Well, they both have a minus 1, really, don't they? Remember, when two terms both have the same thing, you can factor it out, parentheses. That'll leave S squared plus C squared. Do you see that? If I was to take that minus 1, that's called GCF factoring. Greatest common factor, what they have in common. Right? Let's see, whatever you call it, it doesn't matter about the name. Do you see that it's true? If I was to take this minus 1 and go boom, it would go right back to this. And the minus 1 there, it'd go right back to that. It's the same, isn't it? See how it's a different way to say the same thing? See how that minus 1 could see why it changed the sign in the middle to plus? Why? Well, because minus times plus would go back to minus, wouldn't it? See how it effectively pulled the minus 1 off of both of them by putting it in front of the parentheses? It's what they have in common, called the GCF. And it leaves that. Now, why do I want to do that? Well, because I wanted to make this positive so I could use that. See, now this will say, oh, this piece right here, that's just 1. Does everybody see that? This piece right here is just 1, isn't it? S squared plus C squared, that's just 1. So this becomes 2SC minus 1 over SC. We're close. Do y'all see that? Am I losing you? SC minus, why? Because it's 1 times 1 made 1. Right? Because it's a 1, minus 1 here, and this whole thing became 1. S squared plus C squared is 1. Minus 1 times 1 is 1. Good to there? Let me move it over so I think I have 2 small steps left. Slide it over here. 2SC minus 1
I know when you look at
over
my work,
SC.
you're gonna see that it's all squished together. I ran out of room.
Okay, now, what in the world now? Just cancel them out. 2 minus 1, 1.
No.
Right, wrong. Good. I hope you know that. I do wrong stuff all the time, so make sure you're paying attention. That's illegal. Why is that illegal?
Because they're not the same.
Costco says no. Plus or minus. Costco says these are glued together. Package deal. You want to touch this? You buy the whole package or none of it. All or nothing. Plus and minus is glue them together. So I can't do that. I see that mistake all the time, though, so I'm going to constantly be doing it just to make sure you really got it. That'll help you immensely in your future if you're going to pre-calc. So, in calculus, it comes up all the time. So, okay, well, we can't do that. If that was times 1, we could. The issue is the minus, right? If that was times 1, I would totally do that. But it's not. It's a plus or minus. It's Costco glue. It's harder. Plus and minuses make everything hard. So what do you do then? You break them up over a common denominator. Do you see that they have a common denominator? Right? They're like looking at that is like looking at, let's say, 10 minus 7 all over 29. You could make it 10 29ths minus 7 29ths, couldn't you? Get the idea? It's two things over a common element. Break it into two separate fractions. Just common denominator backwards. So in other words, I'm saying make it 2SC over SC minus 1 over SC. Do you see that? See what I just did there? I just separated it over a common denominator. Honey?
Couldn't we just have, in the very beginning, left it separate by just, like...
No. I know, because it feels like I'm undoing, and in a sense I kind of am. You're right. We put them together, and now I'm taking them apart. But I needed to put them together because I needed this S squared and C squared to get together and poof, become 1.
Well, couldn't you have done that anyways if you did sine, cosine, minus sine squared, and then you did...
What? Say it again? Sine, cos?
Yeah, it's like the second
This
one.
one?
Yeah.
Okay.
And then if you separated that, once you put over SC, you would separate that plus sine, cosine, minus cosine squared over SC.
Right.
You couldn't do that?
But how would these ever get together? So no, you understand what I'm saying? You're saying, let me copy what you're saying, SC minus S squared. So you're saying SC minus S squared. Doing the wrong thing here.
Over sine over cosine.
SC, right?
Plus.
And then SC minus C squared over sine cosine, right?
Yeah.
Okay, so what I'm saying to you, Ani, hear me on this. These guys need to get together, or they'll never make 1. So if you got them separate, they ain't ever going to get together. Does that make sense?
Yeah.
So that's why I had to put them together in one fraction so they would get together and poof, they're 1. So that's why I had to put them together, because they had to get together to make 1 for the nice, clean simplification. So I put them together, they made 1, and then I re-separate them. Now, just cancel these out. Is that okay? You guys are like afraid to cancel things now. Benjamin, you're okay with that? Benjamin's always right. I think he pretty much is. Yes, that's right. That's fine. Nobody's glued here. This is shopping at Save Mart. You can buy just one, right? There's no glue here. There's no glue here, right? There's no plus or minus. That's just 2 times S times C. It's shopping at Save Mart. They're separate. You can buy just one. Feel free to cancel the S and the C. See how that separation allowed me to do that? Do you see that? Can you see the answer coming now? So what does that give me? 2 minus 1 over SC. Do you see it? You good to there so far? We're so close. It's in our grasp now. We're inches away. What is 1 over SC? This is sine cosine down there, isn't it? Let me write it out. Sine cosine. What is 1 over sine cosine? Yeah, 1 over sine is cosecant. And you can imagine another 1 up there. What do I mean you could imagine another 1 up there?
You can split that into two fractions and multiply it.
Yeah, exactly. That means 1 over sine times 1 over cosine, doesn't it? That's the same. What's 1 times 1 on the top? Just 1. That's what I mean by you could imagine. It wouldn't be any different. 1 times 1 is 1. Sine times cosine is sine times cosine. So what? Well, that means 1 over sine is cosecant, and 1 over cosine is secant. There it is. 2 minus cosecant secant. It's answer A. Everybody see that? Look at all the algebra rules we learned through that. That's how you learn algebra. You do problem after problem, and you do wrong things, and then your teacher or tutor or friend corrects you, and you learn.
So what happens to the 2?
It's still there.
Okay.
Yeah, look at answer A.
There's.
Yeah, the 2's still there. It's 2 minus cosecant secant.
Okay, that was a mess. Sorry, my
Yeah,
it's there.
mine's a little
It's mess.
messy too. So is that making sense? I think we better move on to another section. So the other ones are on the YouTube, done backwards, 18 back to 13. They're all there.